Okay, good afternoon. Welcome to the Magenta PLM feature-based machining webinar. This webinar will go through a typical prismatic part suitable for feature-based machining where automation is the key requirement. This will explain strengths of NX parametric recognition and the machining knowledge editor. Before we start on the actual webinar, let's just have a look at some of the base points of feature-based machining. So the idea of feature-based machining is that the automation leads to faster, more consistent programming, and that's quite key, the more consistent. Feature recognition is based on defined feature classes or just general topography. It will also recognise product manufacturing information, or PMI as we call it. Modular processes are then applied per feature, and various process variations can be applied intelligently by either defining feature parameters or PMI. In the latest release of NX, NX8, there is also an interactive feature teacher which allows you to teach methods and also processes in the feature-based machining knowledge. Okay, so let's have a look at that in NX then. So I've opened up this typical prismatic part in NX, and we're going to have a look at how we can use feature-based machining to machine many of the features on this part. NX CAM can recognise 60 features from the out-of-the-box templates. In this webinar, we'll just recognise on a few of those features, obviously, and we'll attack this in three different ways. Firstly, we're going to show pre-created operations that have used machining knowledge editor rules for the recognised features. Secondly, we will show some recognised features, and then we will create new operations, and again using the machining knowledge rules. Last but not least, we will then use the feature recognition functionality to recognise new features and again create new operations based on those features. Okay, so as I said, this demo part is typical machinery part, having features which are common on many similar parts, and this is typical of why you would use feature-based machining. The most common feature that we notice here are holes, pockets and notches on the various faces, and we're going to use the out-of-the-box rules to create operations for these features, and we're going to see how easy and how quickly we can do that. Okay, so first of all, let's have a look at the geometry view in the Operation Navigator. So let's change to the geometry view, and for those of you who are used to NX, this will be quite recognisable. We have a machine coordinate system and a workpiece group. If we have a look at that workpiece group, we can see that we've defined the part that we're about to machine, and we've also specified what we call blank material. In this case it's a blank model that's part of this assembly. Underneath that we have various different machine coordinate systems. These are defining the different faces of the component. This is an optional step. You can just machine from one datum, but in this particular component we've chosen to create datums for each machining side. So if we look at the right hand side, we can see that we have a machining datum for that side. Underneath those machining datums we see some geometry groups, and these are slightly different from what we're used to in the normal NX. The feature-based recognition has created these geometry groups based on the type of holes in this case, or the type of slots or pockets that the feature recognition has recognised. And you can see if I highlight these geometry groups, they highlight on screen showing the groups of holes. Let's click on that second one, and so on and so on. And you can see there it's recognised that pocket also. And so these are features that we've already recognised and we've already applied toolpath operations to. And you can see those underneath the groups. So if I highlight those, you can see a typical drilling operation, or in this case, sorry, a spot drilling operation, followed by the drilling operation. If I double click to edit these operations, you'll see that these operations are fairly familiar to NX users, with the slight difference of the geometry groups. The rest of the dialog box should be very familiar to people who used typical drilling operations in NX. And obviously this has been created automatically by the machining knowledge editor, but we can go in there, into these boxes and manually change them if we so wish. Obviously the idea is not to do that, the idea is to automate this process. So obviously these operations are created, the groups are created. The only real job for the programmer is to generate the operation once it's been created. Okay, so let's have a look in the program order view, and we can see in this view we have the different types of operations broken into different groups. So we have spot drilling groups, and milling groups. And you can see this is the knowledge, because of the rules that we have in the knowledge editor, this is what NX has done. It's created these operations in groups. And we'll have a look later how we can optimize these operations to get them in the order that we want. Okay, so these are pre-created features and pre-created operations. So let's have a look at how we can actually create some operations on features that have already been recognized. To do this, we have a look at the Machining Feature Navigator, and if we open that up, we can see that there are many features in there that have already been recognized. And if I open up that box, we'll see that some of these have operations assigned to them. The green tick shows us that, and some of them haven't. So what we want to do now is we want to define operations to these features that haven't got toolpaths already. Let's just refresh the screen there, get rid of that toolpath. So if I highlight one of those features, you'll see that on screen that feature is highlighted. In this case it's a single hole, and we can see a coordinate system in position there. This is showing me the direction that I'm about to machine that particular hole. Makes sense in this case to machine a hole from that direction, but we can change that direction if we so wish. If I right hand mouse click on that feature, I can say edit feature thesis, and then I can define a vector by the usual methods in NX, or I can simply use the dynamics to rotate that vector around to machine that from a different angle. Now obviously with this hole it doesn't make sense to do that, so we're going to leave that as it is. But certainly with faces and pockets you can define the direction of machining. If we click on some of these other features, you'll see again it's showing those in the on screen. So let's pick a selection of these features. I won't pick them all, obviously I can, but the idea is that you would pick them all and then you would create operations for all those features in one go. But for this particular example, I'm just going to pick a selection, and again you see they're highlighted on screen, and you see that different orientations for the different holes. If I right hand mouse click on those, now they're selected, I can say create feature process. And so normally, if we was programming in NX, we'd pick each of these individual features, we'd create operations, we'd use tools either from libraries or from seed files. But what we're going to show now is how we can very, very quickly machine multiple features in a minimum button clicks. So this is the Create Feature Process dialog box, and the type of rule that we're going to use is rule-based rather than template-based. And these are the libraries that are available to us at the moment, and obviously you can create your own libraries and you can define your own processes. For this example, we're going to use this feature-based machining console library. The geometry we're going to set to automatic, but we could define the geometry. This is looking at all the geometry groups that exist inside of NX. But we're going to leave that set to automatic. And the groups, we're going to say use existing. This basically allows the machining knowledge editor to look at the existing groups, the methods, the program order groups, and use those existing. Okay, so I'm going to say OK now. And NX takes a few seconds, but it's now looking at all of those features that I've selected. It's using the machining knowledge editor, and it's creating automatic toolpaths. And you can see how quick that was. So now we've got half a dozen or so operations there, and it's showing the operation status as that it needs generating, and that's fine. That's what we expect. So I'm going to go back into the Operation Navigator, and we can see in the Operation Navigator we can see those ungenerated operations. Let's change to the Geometry view and expand all. And what we see is that actually NX, feature-based machining, has created some new geometry groups. And if I highlight those, you'll see that they highlight on screen. And within those geometry groups, we see the operations. So what I can do now is I'm going to multi-select using my Control key. And I'm going to generate all of those operations. Let's just make sure we've got all of those. Right-hand mouse click and say Generate. And NX will look at each of those operations in turn and generate them. Let's turn off the pause after each path and say OK. Now it will automatically generate all of those toolpaths. Okay, so let's accept those. And now we can see that those toolpaths are generated. Again, we can go into those toolpaths and we can have a look at what they are. Again, just standard drilling operations. You can manually edit those if you so wish. Again, the idea is not to do that, it's to standardize using the machining knowledge rules. And we can see we've created those operations fairly quickly. Go back into the program order view, those operations are added to the various folders within that program order. So you can see there, we've got this particular drilling center operation there. Okay, so as I said, we created about a dozen or so operations there very quickly. The idea would be that you would pick all the features and generate all of the operations together. But you can use the flexibility there. Okay, so with the use of the machining knowledge, the process of creating these operations for so many different types of features, which vary in type, size, machining direction, it just becomes a few button clicks. Okay, so now we're going to see how we can actually recognize these features. So the first example, we were looking at pre-created operations on recognized features. The second example, we had some recognized features and we created new operations. Now we're going to start from scratch. We're going to actually recognize new features and create operations for those features. So again, we go into the Machining Feature Navigator and we see a list of all the features in there. So what I can do now is right-hand mouse click and say Find Features. So this is the Find Features dialog box, and again we have various options of how to recognize those features. We're going to use parametric recognition. The geometry that we're going to look at, we can select or we can define the workpiece group, which we'd already predefined as you saw earlier. And then, let's open this dialog box so we can see a little bit more. Then you can see these are the 60 or so types of features that NX will recognise out of the box. The names of the features can be defined, and you can obviously choose whichever features you choose to find in one go, or you can find them all at the same time. Okay, so in this particular case, I want to find the corner notch straight. So let's select that particular feature. We can define the machine access direction. So we could just tell NX just to find those features that we can machine from a particular direction. And we can define that direction by specifying the normal vector techniques inside of NX. But I'm going to leave that. I'm going to say to NX, just find all of those features that we can feasibly machine, independent of whatever face they're on. Again, we can limit the search area as well, so we can just pick specific faces to look for these features. Again, I'm going to leave that to default, and I'm going to say find features. So NX is now looking for all those corner notch straight features that exist on this component. And now you can see it's picked half a dozen or so features, and we can see those on screen highlighted. Okay, so let's look at these individually by just highlighting individual ones, and we can scroll through this. Now in this particular case, I don't want to machine that face, so I'm going to remove that from my list. But the rest of the features are all good, so I'm going to say OK on that. We now see those features added to the Machining Feature Navigator. What we also see is at the side of two of those features we get this small plus sign, and if I open that up, you can see that underneath that feature we have a surface finish. Now this is where PMI, or Product Manufacturing Information, comes into the equation. Somewhere the designer or the manufacturing engineer has added a surface finish value to that particular surface, and the feature-based machining has picked up on that and recognised that. If I select that feature and then open up the details dialog box, let's just open that a little bit more, you can see that that details dialog box gives us lots of information on that particular feature. And you'll see there that we've got a 6.3 surface finish on that, and the feature-based machining will pick up on that and use that to apply rules to dictate the way we machine that phase. So for instance, if it's a high surface finish, it may create a roughing operation and a finishing operation. If the surface finish is fairly open, then it will just create a roughing operation, and so on. So you can see we can get lots of information, and we can use that PMI, Product Manufacturing Information, to drive the feature-based machining. Okay, so let's find some more features. So right-hand mouse click and say find features again. Again, specify the workpiece, and let's clear all the tick boxes, and this time I'm going to find a feature that we call slot rectangular. There it is. Let's click on that. Again, I could specify machining vectors, I could limit the search area to certain faces, and I'm going to leave that all set and say find features. And again, you can see that we've picked half a dozen or so features on there, and they've highlighted on screen to show us where those features are. Now in this case, I only really want to machine a couple of those features at this point in time. So again, I can select those, and that feature on the side there, that is one that I want to machine, and let's just scroll down there, and that one there, that small notch in the side, is the second feature that I want to machine. So let's pick the ones that are not needed and delete those. So just double click, there's the first feature, there's the second feature. OK that, and again we have those features in the tree, and you can see that they're highlighted on screen if I show those, along with the machining access vector as well. Okay, so I've picked my features. Now I need to create the toolpaths. So let's multi-select, let's close that up. Let's multi-select all of those features that I just found. Right-hand mouse click and say Create Feature Process. Again, I'm going to use rule-based, and again this is the knowledge editor that I'm going to use. Geometry is automatic, groups is use existing. Let's OK that, and again NX will go away. It will look at the machining knowledge rules, and it will create automatic toolpaths to machine all of those features. And there we can see we have those operations. Back into the operation navigator. Let's go to the geometry view. We can see it's clearer and say expand all. And now we can see it's created a geometry group with an operation, and the same again there. So again, we can create those, we can select those groups using my multi-select and say generate. Again, NX will now go away and generate those operations using the automation. Now, something that I haven't mentioned so far is that whilst doing this, what NX is doing is also automatically selecting tools appropriate for the job. And it's using this by looking at the tool libraries. So the feature-based machine is using the built-in tool libraries that exist inside of standard NX. And again, the machining knowledge editor is using rules to define which tools it can and can't use, and then selecting them from the libraries. Okay, so it'll take a few seconds just to generate those milling operations. Okay, let's accept those paths. And again, we could go in there. Let's go into this milling operation, double click, and we can see it's a standard face milling area operation. It's got all the standard features in there that you would expect from any normal face milling area operation. So these feature-based machining operations aren't any different from the normal NX operations. So you don't have to learn a whole new set of operations. These are all exactly the same as you would be used to if you were using NX CAM. Let's just do a replay on that, and you can see that's created a face milling operation to machine those two pads. It's using the inherited clearance plane from the machine coordinate system. Again, this is all built into the rules of the machine knowledge editor. Okay, so we'll have a look at that. And again, if we look in the program order view, we'll see that those operations have been added to the program order view, ready for output to the post-processor. Okay, so we've seen how easily, with the use of feature recognition and the machining knowledge editor, NX is capable of handling different feature types in different directions. It's also taken care of PMI information, product manufacturing information, just in a few button clicks. So we've been reusing established strategies, company processes that everybody has decided on are being reused over and over again. We're using standard tools from a standard tool library. Okay, so let's have a quick look at how we can use some of the tools inside of feature-based machining to optimize our toolpaths. So if we look at this first folder, this spot drill folder, we see that we have different operations, and if I just scroll down those, you can see that they're highlighted on screen. Now in this case, there's an operation on this side of the job, and then we go back to the top of the job. So that sort of doesn't really make sense. You'd have the rotary axis of the table would be moving around a little bit too much there. It wouldn't make sense. So what we can do on this particular folder is we can right-hand mouse click and say Object, Optimize. We can consolidate all the tools, we can minimize tool changes if there are any, and we create what we call an optimization group, which you'll see in a moment. So if I OK that, it creates these two optimized groups, and if we look underneath those, we can see that now the operations are grouped together dependent on the axis that would be used for that operation. What we can also do is, if we then double click on that optimized group, we can optimize it even further by minimizing tool travel, or we can actually machine the holes in bands, so we can go vertical or horizontal. If we say minimize tool travel and hit the edit parameters button, you can see that we can select a start hole. So if I go in there and say select, it shows all the holes that I'm machining in this operation, and if we just zoom in and pick that first hole, OK that, let's use advanced method and say resequence, you can see that it's now resequenced the order of those holes to minimize the tool travel. OK that, regenerate, and OK that. So you can see, not only can I create these toolpaths very, very quickly using standard processes and standard tooling, I can also optimize the process to give me my minimum cycle times. Okay, so last but not least, while we're looking at this, you may have noticed that this is part of an assembly. We can see the whole machine has been modelled up, the kinematics of the machine in there. This is the functionality in NX that we call IS&V, or Internal Simulation and Verification. We're just going to have a quick look at that. Let's pick the milling operations, and let's say right-hand mouse click and say Toolpath Simulate. And then what we see various options to how we want to simulate this. We can show 3D material removal, and NX will build up a representation of the blank material that we've defined. We can also, under options, we can check for collision, and we can specify the components that we want to check for that collision. These can all be built into a template. Obviously, you wouldn't have to set these every time you use this operation, but these are just some of the features that you can use. We can then specify whether we want to actually simulate the internal toolpath or the actual post-process toolpath, which is always a good thing to limit the time spent on prove-outs on the shop floor. So let's say machine code simulate, and you'll see when I press go that we're actually simulating the G&M code, if you like, that's been post-processed. And just speed it up a fraction, and if I press play, so you can see there in the window that we are actually processing G&M code, and we can zoom around, move in, and we can see that we're actually simulating post-process code there. And as I said, we can check for collisions, we can check for material removal, we can check that we're not machining the finished parts, that we're leaving enough material on, all the usual things that you would expect from a simulation package. Okay, let's stop that there. So that's just a little flavour of the simulation package that exists inside of NX. Okay, so that concludes the webinar today. First of all, I'd like to thank everybody for attending, and if there are any questions, then please feel free. If there aren't any questions and you think of questions later, then feel free to contact myself or your account manager for further details. Hopefully you found something useful in the webinar today, but other than that, I'd just like to say thank you and goodbye.